In this video, we will talk about DBMS keys. Students are always confused about this concept as there are many different kinds of DBMS keys and almost all are related to each other with a slight difference, which makes it very difficult at times to get a clear understanding. In this video, we will learn what are database keys, why we need these, and the different types of the DBMS keys. A database key or a DBMS key is an attribute or a set of attributes which help you uniquely identify any record or row of data in a table. Let's take an example. In the table above, we have SID, SName, SBranch, and SEmail as attributes, saving details about students. If I ask you to tell me email address of the student with name Adam, can you tell me? No, because there are two students with name Adam. Or if I ask you tell me name of student who is in CS branch, again there will be many students in that branch. But if you look closely, SID column has unique value for all the rows of data, and the SEmail column also has unique email addresses. Hence, these two columns can be used to identify records in the above table. So we can say that SID and SEmail are keys for this relation. This brings us to the question, why we need keys? The first reason is pretty much obvious. Without a DBMS key, you cannot access the rows of data stored in the table uniquely. Because without a key, most of the time you will either receive multiple rows of data or incorrect rows of data. Another big reason, which is kind of an extension of the first reason, is we can force identity of data and ensure integrity of data is maintained using DBMS keys. By making an attribute a key and making it mandatory, we can enforce that anything inserted in the table is identifiable, hence ensuring data integrity too. And last but not the least, we can establish a relationship between tables using keys. It's time for the main event, types of DBMS keys. There are 8 different types of DBMS keys, of which super key is like the default key, and composite and compound keys are like cousin sisters. We'll see when we learn about them. So we will be starting with super key, then we will move on to candidate key, then primary and alternate keys, then the foreign key, which is different from all others and serves a purpose which none of the other keys do, and then we will cover the remaining keys, which are composite, compound, and surrogate. Super key is nothing but a key. It is a superset of keys in which all possible keys are included. Like in our example, SID, registration ID, email, then combination of them, SID, registration ID and email, email and SID, and then all three together, SID, registration ID, email, all are super keys. There can be more as well. In simpler words, an attribute or a set of attributes that can be used to identify records in a table is a super key. Then comes candidate key. It is the minimal set of super key which can be used to uniquely identify rows of data in a table. We saw that we have so many options for super keys, but most of them are formed by unnecessary pairing of keys, like email ID, SID, registration ID together as a key, or email SID as a key, when email SID and registration ID can individually uniquely identify a row of data. Hence, in this case, the three attributes SID, email, and registration ID or reg_id are the minimal set of super key, hence the candidate keys. Speaking books language, if any proper subset of a super key is a super key, then that cannot be a candidate key. Now let's try to understand this. Registration ID, email, and SID together form a super key, while email and SID is a proper subset of it and is also a super key. Hence, this is not a candidate key. Similarly, email SID is a super key, and its proper subset, email and SID, both can act as a super key individually. Hence, this is not a candidate key. This way, we can come to a conclusive proof that SID, email and registration ID are the candidate keys for the relationship that we have. Now, moving on to primary and alternate keys. A primary key is a candidate key which is used to uniquely identify every row of data in a table. Now you must be thinking that we have 3 candidate keys and all of them can do so. Well, in that case, you can make anyone a primary key. This is generally done by database administrator to set a candidate key as a primary key. If we have to create a simple user interface to search for student information for our college using the table in the database that we have as an example, what will make more sense? SID, which is an auto-incremented value by the database itself, or registration ID, which every student knows and is more meaningful for college administration too. Hence, in this example, we can make reg_id or registration ID as primary key. All the remaining candidate keys which are not selected as a primary key are called alternate keys. Now, coming to foreign keys. Foreign key is nothing but an attribute in a table which is used to create a relationship of that table with some other table. In case our tables have relationship, using foreign keys helps us to maintain data integrity for the relationship. For this, we will have to involve another table in our example. Let's say we have one more table, branch, with information about the branches in the colleges. It has a unique column with branch code, branch name, HOD, and some more branch related information. In the students table, the branch code can be made a foreign key to set up referential integrity or relationship between the table student and branch. This way, while making a new student entry, a wrong branch name cannot be provided, else a DB will return error. Similarly, if someone deletes a branch entry or updates a branch code in branch table, they will have to change the same in students table too. Generally, this is not allowed by the database, and the database returns error when someone tries to modify the column value which is used as a foreign key in some other table. Hence, this way we can force integrity of data in a relationship using foreign keys. Moving on to the remaining keys, a composite key has multiple attributes. Hence, all the super keys with more than one attribute are also composite key. In our case, email SID together, SID registration ID together, registration ID email together, all are composite keys. If a composite key has one attribute which is foreign key, then it is called a compound key. Moving on to the surrogate key. Sometimes a relation or a table has no attribute which can uniquely identify the rows in the table. In this situation, when there is no natural primary key, we create an attribute to act as a primary key, that is a surrogate key. These keys do not add any meaning to the data, but serves the sole purpose of identifying the data. With this, we have covered all the DBMS keys, starting from super key, candidate key, then primary key, alternate key, foreign key, composite and compound key, and surrogate key. I hope after watching this video you have a better understanding of what DBMS keys are, why they are required, and the various different types of DBMS keys.